Okay, we're finishing up. This is example 1 still from section 4.4. Just ran out of room, so last 2 problems here. So this is part E. This is going to require the product rule. But anytime you ever see a square root in a problem that is asking you to take the derivative, or any kind of root, in fact, you're always going to want to write that as a power so that you can use the power rule. So notice that when we do that, I mean, either way, we have a product of 2 functions. So we're going to have to use the product rule. And we're also going to have to combine it with the chain rule in 2 cases. This is a chain rule, that's a chain rule. So we're combining the product rule with the chain rule. And again, this is y as a function of x. So the derivative is called dy dx. All right, so product rule, we'll take the derivative of the first function, which again, remember, if it's e to some power, first thing you'll want to do is copy it. So we get e to the power of x to the third minus 2. And then multiply by the derivative of the thing up here, which is going to be 3x squared. Again, the derivative of 2 is just 0, so that goes away. Multiplied by the second function, so that's 2x plus 5, the 1/2. And then add this to now the first function, that's this again, times the derivative of the second function, which itself is going to require the chain rule. General power rule, remember what we do there is put the 1/2 in front, copy the stuff that's on the inside of the parentheses, lower the power by 1, so that's going to give us negative 1/2, and then multiply by the derivative of the thing that's on the inside of the parentheses, which is 2 in this case. Okay, we can simplify this somewhat. Notice that the 2 here, and then we've got a 1/2 here. Those are just going to cancel each other out, so the 2 and the 1/2 cancel. Let's go ahead and move that to the denominator since it's a negative exponent, and we'll rearrange the order on this stuff here. So we'll get 3x squared e to the power of x to the third minus 2. And let's rewrite this as what it was before, square root, so 2x plus 5. Okay, that's the first part. Then we'll do the second part. So that has e to the x to the third minus 2 in the numerator. In the denominator, that's a negative exponent, so that'll move that to the denominator. Since it's a 1/2 power, it's a square root. So we get this for our final simplified answer. Okay, then for part F, let's see what we got on F is f of x is 100 over 5 plus 2e to the power of negative 0.1x. Okay, so what I suggest in problems like this, where you have only a constant in the numerator and some function in the denominator, is to go ahead and rewrite it so that it has a negative exponent. Then you can just use the power rule, or the general power rule, instead of the quotient rule. So we can write it like this. And then since I moved this from the denominator to the numerator, that becomes a negative 1 power. Okay, now I'm just calling this thing f of x, so I can use the other notation for derivative, just f prime of x. And then here we're going to use the general power rule. That's a chain rule, so we'll put the negative 1 in front, so minus 100. And then copy the function that's inside. And then lower the power by 1. And then we have to multiply by the derivative of the stuff that's on the inside of the parentheses here. Well, the derivative of 5 is 0. Here we've got an exponential function, so we use the rule to take that kind of derivative. So basically we just copy the function first, 2e to the minus 0.1x, and then we multiply by the derivative of what's up there in the exponent. Well, that's just a constant times x, so its derivative is just the constant, so we're going to get 0.1x. Okay, we can simplify this a little bit. All of this is being multiplied together, so I can take that 0.1x and the 2 and multiply them together and then multiply that by the 100. So that's going to be basically 0.1 times 100 is going to be 10, and if I multiply that by the 2, I get 20. I got 2 negatives here, so they're going to cancel. So I'm going to get 20. I have that x and I have that. I'm going to move those to the front as well. So x e to the power of minus 0.1x. So I've moved all of the stuff to to the front here. I've multiplied the constants, and of course we're able to do this because multiplication again is commutative. This times this times this times this. We've got 4 things multiplied together, so we can put them in any order we want. We can combine these constants by multiplying them. We can put the x in front, we can put that in front, and then that's a negative exponent right there. So I'm going to go ahead and I could just write that as, copy it and put it there, but since it's a negative exponent, I'm going to go ahead and put that in the denominator. So we'll get 5 plus 2 e to the minus 0.1 x, and all of this is now to the positive 2 power since I put it in the denominator. So there's our final simplified answer on this problem. Now keep in mind, if you're doing a problem like this on My Math Lab, and you certainly will be, if you entered the answer like this, it would take it. It would definitely take it. But for the purposes of what we want to do with these things later, it's definitely nicer to have the answer in its simplified form.